Hello guys, so today is the day one of starting the deep learning machine learning playlist. So today we are going to start the deep learning basically. Deep learning is the best part in machine learning, or we can say the in artificial intelligence field. So today we are going to see like some basics like what is neurons, how this can work basically. So let's start the deep learning playlist. You can find it in the chat section also. Let's start. Like what is deep learning and how to use all of these, we will see it. Complete deep learning. Inside the deep learning, where is this? Deep learning. Deep learning. Okay, this is the file. Let's start the deep learning playlist. And here you are going to understand each and every concept of deep learning. So let's start where the deep learning comes in the field of AI. Suppose this is the AI universe you are seeing. Like wait, I will take a pen and let's start. So here we are. So this is the universe, suppose, of AI universe basically. So any algorithm that is related to machine learning, deep learning, NLP comes inside AI basically. And this part is basically the machine learning part. So any deep learning project that you are doing which comes inside the machine learning. So this is the area that you are seeing is the basically machine learning, not deep learning part basically. So here we are now. Now let's start our deep learning playlist. So inside deep learning, basically we will learn about ANN, CNN and RNN basically. So now what is ANN? Artificial neural network, and CNN convolutional neural network, and RNN recurrent neural network. So basically deep learning is the vast field you are now learning. Any problem related to basically which you cannot get good accuracy in machine learning, like some problems, some basically algorithms are there like linear regression, logistic decision tree. If you are not getting a good accuracy, then try to use deep learning. Otherwise not start try to use deep learning. If you are getting a good accuracy in traditional machine learning algorithms like linear regression, logistic and decision tree, then don't use deep learning, because inside deep learning you have to know many more things related to ANN, CNN and RNN. So if you are using a simple architecture, then that's known as ANN, artificial neural network. So in ANN you can solve any classification and regression problem. And for CNN, basically convolution neural network, if you are doing any image related problems or video related problems, then you have to use CNN. So inside the CNN, basically RCNN, recurrent convolution neural masked, RCNN detection, YOLO side like version 5, 6, 7 and 8, now 9 or also comes. So if you are doing any image related or video related, or we can say image segmentation, anything related to image, you have to apply CNN. And the third one is RNN, recurrent neural network. So if you are using a project related to text, NLP, time series, then use this recurrent neural network. You can also use CNN in text, but the accuracy you will not get a good. So this is the traditional, like if you want any project related to image and video, then apply CNN, and for NLP, if you want a good accuracy, then apply as RNN. And now most of the frameworks, no, most of the models are coming like TensorFlow, BERT, ChatGPT. Now this will come, but basically we will touch only RNN, like how this will work in this video. And I've already told you like the attention is all you need. A research paper where I have taught you teach you like in-depth intuition of basically transformer. Now, so the framework basically we will use our TensorFlow library, which is the very best library to predict any like to use a deep learning project, machine learning deep learning project we have to use. So inside text, basically bird embedding, LSTM, RNN, GRU, RNN, bidirectional LSTM. Basically, this is related to NLP part. We will see in the next playlist, which we will learn about in NLP. Now, but in this, basically, we will learn what is ANN and CNN related task in this playlist inside the deep learning. So now let's start. Why deep learning is becoming popular? So this is the question like why deep learning? So before 2005, basically we are using a web 1. But after 2005, basically the web 2.0 is come. So inside by using the first web 2.0 is used by Facebook. So they have implemented our database. Firstly, all of these things but happened before 2005 is only in the basically in the web. But after 2005, they will come into our database, and all the database is data is being stored inside the database. So we have a rich of data after 2005. We have collected lot of data after 2005. So in 2011, 12 data was generated exponentially. Like data is generated huge and huge lot of data. So now after 2011, big data will come like Hadoop, which is unstructured data. Like you are using also known about MongoDB. This is also unstructured data. So because of the rise of this big data, we are able to create deep learning project. Because if you are implementing a deep learning project and you want a good accuracy, then you have a very huge data size basically. So that's why after 2005 we have generated like come into 2.0 web and social media platform like Facebook, YouTube, WhatsApp. So we have generated a lot of data and stored in database. So now we will see like, so that's why deep learning is popular now. Or suppose this is the performance, like also we can learn like Netflix, more streaming platform, recommendation system, these are coming nowadays. So this is the data size. If you apply like if your data is increasing somewhat like 1,000 data points like here, then you will get a approx similar accuracy by traditional or deep learning. But if your data size is increasing by exponentially, or we can say a numerous, then your deep learning model will perform very good. You can see that. So that's why deep learning frameworks are now very popular rather than traditional machine learning algorithms. That's why everybody is using nowadays deep learning frameworks. You have seen many lot of problems nowadays like ChatGPT, BERT, and we can see that Delhi and Mid Journey, all of these basically project that you are seeing, it is depend on deep learning. Like also hardware requirements. Basically in 2011 or 12, hardware is also now a cheaper and cheaper nowadays. Before 2010, it will be very costly. Nowadays, it will be very cheap, and you can train any models. And NVIDIA is working nowadays very good bulks. They are every time reducing its price of GPU, Basically, to train this model, GPU is required. If you will train your model on CPU, it will take lot of times. Like if you will train a model in CPU, it will take 1 hour. But same data and model, if you train in GPU, it will take only 1 minute. So see that, like how this will be 100 times basically more efficient than CPU. So deep learning is being used in many domains like medical, e-commerce, retails, market. Like everywhere nowadays is using deep learning frameworks only. Or frameworks open source, basically TensorFlow is made by Google, PyTorch is by Facebook, and many more research is now going. So if you want to create a deep learning project, then basically use TensorFlow and PyTorch. Basically in the industry nowadays, 60 to 70% use TensorFlow. So learn TensorFlow basically. It is essential. PyTorch is also learn you can, but it is not recommended. Like you can learn, but if learn TensorFlow if you want to learn deep learning. TensorFlow is the very good library to implement a deep learning project. Now, coming to the bit, I am coming after 1 minute. I want to drink some water. Hello guys. So now we will start our perceptron. So what is perceptron? Artificial neural or neural network unit. So basically ANN is basically, if you will see your neurons inside your head, it is basically mimicking our human brains. Perceptron is basically inside our head. So they have taken the word perceptron from the neurons basically. So here you can see, if you see a human brain's perceptron and a deep neural network architecture, this will looks like same. So they will comes of idea of this deep neural network according to this human brains. Like every neurons is connected to every other neurons. So that's why they are doing the same things inside this perceptron basically. In this artificial neural network, basically we have input layer, hidden layers, bait, and activation functions. Now this is some confusing if you are learning from the first time. Let's understand what is input layer, hidden layer, bits, and activation functions. So here you can see x1 and x2. This is basically your input layers. If you see a deep neural network, only one is the input layer. You can see that, and this is predefined. If you are training a model, this is basically a hyperparameter, you can say. You everything inside a neural network, or we can say a deep learning model, many things like 80 to 90% are hyperparameters. Like number of input layers, basically this is also a hyperparameter. So now let's see, like x1 and x2. if you give some input like x1 and x2, this is your input layer, this will go. And inside this here you can see a circle. Basically this is a neuron, we can say that neurons. And there are a lot of tons of neurons are there, like 30 billion neurons, not neurons, because say a bit tricks are now we train on chat gpt, or now new models will be coming which will takes approx 13 billion neurons maybe. You can see that, read this. So this is the input layer, and hidden layers also like are there. This is called a hidden layer. Basically, there are many hidden layer in your neural network you can find out. And bits. These are W1 and W2. Here you can see. Basically, this is the W1 and W2. These are the bits, and this is the main thing in a neural network. Basically, bits. Basically you have provide input, and input will be do some calculation on top of a bit. Like if you provide x1 and x1 into w1, x2 into w2, and some bias will be added, and then this calculation will be passed through a activation function, and activation function will be applied. There are a lot of activation function are there. I will teach you in next lecture. Like activation function is play a very crucial role in the deep learning. So activation function is applied on top of the summation, or we can say that calculation, and then this is the output of your first, we can say, a neuron, and this will be passed to the second hidden layer, and second hidden layer will again do some calculation according to these bits, and that's the process will be go continuously. And after this will predict some output. Suppose here we can see our input is IQ. Like suppose we have a data set x1 and x2, IQ is there, and according to IQ there is number of hours of study. Like if you have a IQ of 95, and if you will study 3 hours you will fail, and if you have a IQ 110 and number of hours you will study is 4, then you will pass, and this is the third output. So in the first epoch, we have to pass all of this data. Like 91 will pass from here, and 3 will be passed from here, and we have done some calculation and then apply activation function, and this will be continuously done until our neural network does not predict. Basically, we have defined some shape of this, like number of hidden layer and number of neurons. After all the calculation will be done inside this neural network and predict some output. Suppose this will our new output, and this will predict a one, and we have said output will be 0 at the time of training. So now we will calculate some loss. There are some loss functions also there, like hinge, hoover, and msc, rsc, like rmsc. You have to calculate this loss according to this formula which you have applied. Basically this is also a hyperparameter, a loss function. You have to apply it, so you will get some error. So after this you will get a error, then you have to apply a optimizer. Some optimizer is also we have to apply, and according to this optimization function we have to backpropagate. At the time of backpropagation we will change these bits and biases. So now we will say, like to our model, like you have predict are wrong, now change this bit according to, so that I can get a good answer. Basically we say I am not getting a good answer at this time. Like our model predicted one, but the actual answer 0. So there is some error in our model. So at the time of back propagation we say no, this is not a right bit, change this bit so that I can get a good answer. Basically, so at the time of back propagation, we will say to this model, and this bit will be reinitialized, like, or change according to this optimizer that we are using. Mostly nowadays we are using Adam optimizer. Adam optimizer is the best optimizer. Like 99% basically in models, Adam optimizer is used. Let's see after some time, like why we have to use Adam optimizer. Remember this word, like 99% of models using Adam optimizer. We will learn all of these at optimizer like 7 to 8, but mainly Adam optimizer used. Like why we are using Adam optimizer, we will see after some times. So that's like how ANN is work inside activation function. So suppose we are using a binary classification here, 0 and 1. So for this binary classification we use a sigmoid activation function. Basically sigmoid activation function which will gives our output into 0 to 1. And that's for sigmoid. And we are using a softmax. We will see like many activation function are there. If you are using a multi-class classification, then we use softmax. And if you are using binary, so then we can use a sigmoid. Here this is a binary class classification problem, so we can use a sigmoid activation function. So activation function basically transform our output into 0 to 1 or minus 1 to 1. Basically we will see many other activation function will give output according to this implementation of the. So let's start like step function. You like see it, this is a sigmoid function which will gives output between 0 to 1. And if you like now at the time of training, we will say like if the output the sigmoid function giving greater than 0 0.5, then this will be gives in the 1 class and first class. And if the output is basically of sigmoid function is less than 0 0.5, then this gives in a 0 class. Basically we will define a threshold. Basically threshold is also a hyperparameter. This will be also trained at the time of training our model. We will see it like how this will work. And so for this perceptron is basically this is a linear regression, and this will be applied activation function, sigmoid activation function. If you applied, then this will give output like this. If you have a value less than 0, then this will be a 0, and greater than 0 it will be a 1 class. Step function is this. So in step one, basically, I have already told you like we will provide some input, and input will be multiplied into weight matrix. So we will get x1, w1, x2, w2, something like that, and some bias is also added. Bias, now the point is like why bias? Basically biases help us sometimes to get a right answer, because if you be applied like x1 x2 x1 into w1 x2 into w2 something like that, then sometimes this will not perfect well. So we have add some bias so that it will also a hyperparameter that will be help to get a good answer basically. So y equal to mx plus c, this is a linear equation, and this is also we can get a linear equation. And on this linear equation we apply our activation function. Let's see perceptron model. So that's we have seen single layer perceptron model. This is like here in step 1 we apply x1 xi wi plus bait. This is the xi basically your input bait, and w these are hyperparameter bait matrix. And then we have applied on top of this activist on top of this z is the activation function, and apply some threshold value so that we can get a right answer like 0 class or 1 class maybe. So multi-layered perceptron model will have forward and backward. I will already tell you. So backward propagation will help us to deinitialize bit so that we can get a good answer. And also we have applied a loss function. Basically for this we have applied a binary cross entropy. I think binary there's some loss function is also there. We will teach. I will teach you. And some activation function is there like ReLU activation function is there 10h, and also sigmoid softmax activation function is there. And the best activation function is I think ReLU like most of the function we have applied a ReLU activation function in between basically, and the output we can change according to this our output basically. And optimizers is also there, many optimizers like gradient descent, stochastic gradient descent, mini batch stochastic gradient descent, and SGD with momentum, ADA boost, gradient boost, and the best optimizer is Adam optimizer. Basically, we will learn it. So suppose if the data is linearly separable, then we can apply a traditional algorithm, and this is a binary classification, linearly separable. Suppose if your data has something like this and this, so now we cannot distinguish by linear line. So here deep learning will comes. Like if you have a non-linear separable data, then we have to apply multi-layer neural network, and so this will be able to solve our problem. You can also apply PCA to reduce the dimension of 2 to 1, and you will get some answer. But if you apply directly a deep learning, then you will get a good answer. So that's why we are learning deep learning. You can also solve it this non-linear separable data by our traditional machine learning algorithm by applying some PCA and BCA, but you have to know some in depth if you are applying traditional. But inside a deep learning, you don't have to know very much. Only apply a machine learning algorithm and provide a data. This will automatically learn all of these things. So now multi-layered perceptron model, artificial neural. So this have a forward propagation, backward propagation, loss function, optimizers, activation functions are there. So this algorithm is basically created by Geoffrey Hinton. This man is basically a very, we can say, uh, very very knowledgeable person. He knows how humans mind works, and so he mimicked the humans in the math, and he gave a name as a deep learning, so that nowadays we will train any model on this deep learning. Now let's see how this will work. So x1 x2 x3, basically this is your input layer, and we have basically initialized some bit to this edit. Firstly we will initialize randomly, and the time of back propagation this will be learned automatically, and apply also some bias, and this is your hidden layer basically, and this is your second neurons, basically second layer we can say. And this output of this like x1 w1 x2 and some bias added, this will we will apply some activation function, and then this output of this activation function to this pass as an input to the second neurons, and second neurons again do the same thing that we have done previously, and this again we have applied something and then apply a loss function, and then we will get some loss, and then we will apply our optimization technique. Like optimizers is there, so according to this optimization we will change this bit. We will have some, like you have learned about gradient descent, so that's here also we can apply. So this will help us to change these bits to basically change this bit so that our model will learn according to this output. We will already taken this input, so according to this, suppose at the w1 w2 w3 will be initialized, and the time of backpropagation we will change according to our output. Basically this is the for a binary classification we apply a sigmoid activation function. So this is the sigmoid activation function is 1 upon 1 plus e raised to the power of minus z. So this is the activation function will be applied, and we will the 0.5 is a hyperparameter now, but you can change at the time of training, and the machine learning model will automatically will change according to this training. So if the output is coming 0.79, then this will goes to a 1 class, and your output will be 1 basically. So and then again we will give this output to this model of to the second neuron, and second neuron again apply some weight and then bias, and this output will again apply like sigmoid activation function, and this will give some 0.5, so this will be a one class basically. This all calculation will automatically done by our deep learning model. You don't have to do worry about it. You have to only create a model only. Now back propagation and bit updation formula. So back propagation is basically uses some optimizers. Basically, the best optimizers nowadays, I have already said Adam optimizers, but to understand, for you have learned about gradient descent, I think. So basically, gradient descent will help us to change this bit according to our loss. If you are getting high loss, then this will be changing this bit according to this formula. And there's some also basically learning rate. According to learning rate, also we have to change these bits. So back propagation will be after first epoch, the back propagation will be done. So to according to back propagation, our bed will be changes. So if you are using a regression problem, then the loss function is MSE, MAE, Huber loss, hinge loss is there. For classification, we have binary cross entropy and categorical cross entropy. Binary cross entropy, and categorical cross entropy. So in binary cross entropy, basically, if you have a output like binary, so we will use 0 or 1s if you have two class. If categorical cross entropy, if you have a multi-layered multi basically multi-layer, not multi output, then we have to use categorical cross entropy. So according to this error, our bit updation will be held inside this neural network. So bit updation formula we have already learned, like in gradient descent. We want this global minima. Inside the gradient descent, we have learned W nu equal to W old minus eta into derivation of loss function with respect to weight. And for bias, we can also apply this formula. So bias and weight, for every bias and base, this will be applied, and this will be changed according to this. If you like weight is coming here, but we want weight here, like we want a weight so that our like the loss will be minimum global. We want a basically a global minima. Basically, this is the your loss. Basically, this is your loss. We want a minimum loss. So to get a minimum loss, we will apply some loss function. So for regression is MSC this is the, and to help this loss function to get a loss minimum, we have some optimizers. So basically, gradient descent is one of the optimizers, and nowadays we are using Adam optimizer inside the deep learning. So this is the formula for gradient descent to update this weights. W new, we have already told you weight updation formula. This is gradient descent. So if you are getting error here, like, then you optimize just gradient descent will automatically say that okay, we are here, we have to now change. Basically, the bed will be low. We have to add some bed on this one. The formula will automatically work. If you getting some negative, then it will be added some bed, and according to this formula, automatically work. And this is also a learning rate. Learning rate basically here, if you are here, then this will say the learning rate will be high. If you are getting some here, then the learning rate will automatically. In gradient descent, the learning rate is fixed, but in Adam optimizer, this is also momentum based. According to this error, this will automatically will be changes. But learning rate is also would help us to get a global minima. So suppose if you want to verify this formula, like suppose you are getting a like W. W means your bit matrix. Your bit matrix or bit is coming here. Then if you see a slope of this is positive. So if you apply a positive, then you will get some formula, like if you apply a positive here, then you will get some negative. So you see that we have to decrease the weight. If you have a weight something like this, then if you apply, then this will say you like slope is negative. So if you give negative into negative, it will be positive. So now you have to say that our model to go to in the right direction, so that our your formula will automatically work according to this. You don't have to worry about this. W new, this will all done. Like chain rule of differentiation. So chain rule of differentiation, let's see like how this will work. So firstly, basically derivation, if we apply derivation of loss with respect to weight, so derivation of loss with respect to O2 is done. And according to O2, we will apply on find a loss on that and then apply again a derivation on this. So this will be the output of the derivation of basically O2 on with respect to basically weight of fourth. So now again this will be a derivation. Now we are now find for derivation for this one, and now we will get a derivation of O2 with respect to derivation of W4 old. Now again we have to apply like derivation of H. H basically our error with respect to W old. This will be again a W loss with respect to O2 into WO2 by O1, O2 by O1 output, and this will apply again and again. So you will get a very huge complex equation like this. W of loss with respect to O3, and O3 का derivation with respect to O22, and O22 का differentiation with respect to O12, and O12 का differentiation with respect to O1 like W. So basically this known as chain rule of differentiation. So due to this, you will suppose you have a very huge model, deep neural network. Then suppose at the time of back propagation you are applying this formula, then the initial layers of this neural network will be not training. You will see if you apply this. Like if you multiply derivative of some like 100 with respect to something, and then again apply a derivation of 100 on something, like if you have a x square function, then apply it on x cube. Let us suppose you have a function of x cube, and if you apply some value like 2, 2 of x cube is 2 of power 3 is 8. Now you have done derivation on that and you will get some x square, and then again x square you have to do a derivation, then you will get x. Again if you apply a derivation of x, you will get a of 1. So every time if you apply this derivation, you will get some small value every time. Suppose you have a new model which have 1000 of layers, something like that. You have to do 1000 times of this derivation. So at the time of the initial layers will be not training, you will see not training in a very well, or we can say this will be not, the bit will be not changing, it will be some minute changes will be neglected. So your model now will be not training very well. So to avoid this situation, we apply some good optimizers like Adam optimizers. So all this problem called vanishing gradient problem, we will see like due to chain rule of differentiation, this problem will be occurred. So in this problem basically the bit of this initial layer will be not changing, and the second problem is basically vanishing gradient problem, and the second problem is exploding gradient descent problem. In that basically the bit will be changes very huge, so the bit will be learning very fast. So this will also a problem. We want something so that our model will be learn in a good manner basically. So due to chain rule of differentiation, our model's initial layer will be not learning well. So to avoid this, we will apply some skip connection nowadays. You have seen in our transformer, or you can see in basically unit architecture is there. So inside a unit architecture we apply skip connection, so that our inside in skip connection we will basically create a connection between layer of 100 to third layer, so that our bit will be directly goes from 100 to 3, so that our updation formula will be perfect fine. So that's we are to reduce this balancing gradient problem, we are now using escape connections. And that's it for escape connection and balancing gradient problem. So balancing gradient problem will be occurred due to chain rule of differentiation. So our bit will be not update in a good manner. So this problem was also occurred in RNN. RNN is fails due to balancing gradient problem. That's why they comes into a second architecture like LSTM, and after that LSTM they will comes in a transformer. Basically transformers is the best architecture that you have to learn for this deep learning frameworks. Now sigmoid activation function, softmax and sigmoid. Basically sigmoid activation function will have a balancing gradient problem. Basically how? So your output will be ranges for the sigmoid is basically 0 to 1. If we apply this formula 1 upon 1 plus e raised to the power of minus z, our output will be ranges from 0 to 1. So and then we will do a derivation of this function. If you do, you will get a value from 0 to 0.25. So if we apply again chain rule of differentiation on this formula, you will get every time a lesser and lesser and lesser value. Like if you are getting 0.000 something like that. So now your bit will be not updating in a good manner. So that's why the sigmoid activation function we don't have to apply in between of this layer. You have to apply on the sigmoid function at the last layer of this output. If you are using a binary class classification problem, then apply a sigmoid at the output layer. Don't apply sigmoid inside between. If you will apply this function in between, you will definitely will stuck a local minima. Local minimum is you will not get a good accuracy, or you have get a vanishing gradient problem. So this is the lack of sigmoid activation function. So we don't have to apply this sigmoid activation function because of chain rule of differentiation. If you apply again and again this formula, you will stuck in local minima. See, so derivation of sigmoid function, you will get this one. To fix this problem, basically researchers started exploring other activation function. Basically researchers are the main, they are doing some research to get you a good answer. So your model is now not performing well, so they have create a second activation function like relu 10h pre-relu, or basically lick relu, or Swiss is also there. We will learn about this function, all of this. Nowadays, basically, ReLU is the best activation function inside. If you want to train a good model, in between, sure, apply a ReLU activation function to get a good accuracy. Or leaky ReLU you can also use. Like now we will see like why we have to don't use 10h and why we have to don't, like we will see like which is the activation function we have to use and why we have to don't use a sigmoid. You can use, you cannot, you have to use a sigmoid function in the last layer only. In between don't use a sigmoid activation function. And softmax activation function is also there. If you are using a multi-layer class classification, then use a softmax activation function. So let's see all of this activation function in the second lecture. For today, that's it. Let's see like activation function in the how sigmoid function is work, and softmax, and like 10h, relu, leaky relu, swiss function. All of these function we will learn in the next lecture. Basically, like activation function and optimizers are the best part of deep learning. Basically you have to know all of this. If you want to learn a deep learning in a very good manner, then you have to know all of these activation function and optimizers. Basically these functions will help us to get a good accuracy of our deep learning frameworks of this model. So you have to know all of this framework. If you know All of this like activation function and optimizers, you are now ready to implement your model. But for CNN, you have to learn something like other things like what is stride, what is basically our input CNN models, like pooling layer and some average, like many things are there we will learn in CNN. For today, that's it. Like I have explained the ANN model, like artificial neural network, how this will work. Now let's see all of this activation function in the second lecture and optimizers also we will see. That's it for today, guys. Thank you, love you, Jai Hind, Jai Bharat. Please subscribe also my channel to get a good content like this. I am explaining in the right manner, like why we have to don't use this function and why we have to use this. Why they are coming to this next like optimizers. We will see it like what the where sigmoid is lacking, so they have created a second activation function like this. We will see it. If you will learn in this manner, you will get a good understanding of this things. ओके गाइस, तो मिलते हैं दूसरे सेकंड लेक्चर में. लेट्स मीट इन द सेकंड लेक्चर. थैंक यू गाइस, सब्सक्राइब माय चैनल.